NOCPlan XS is the planning tool that addresses outside plant fiber and access planning and optimization. It has been designed specifically for global communication service providers who are moving from an all copper based outside plant to all fiber or fiber copper architectures. This is how a NOCPlan project looks like. It comprises of different areas referred to as workflows, the control area, and the GIS display area or the map area. NOCPlan XS integrates geographical information system technology into its map display area and provides a flexible platform, a foundation that supports each phase of the network planning process by putting all the relevant information into a geographical context such as boundary, roads, poles, etc. Now coming over to the input to the NOCPlan. Since NOCPlan is a network planning tool, it requires some data to be fed into so that network is planned in an optimized manner. There are three ways of inputting data into the NOCPlan application. First is by importing the map files, which are nothing but .shp files. The second is by importing the CSV files, and third is by manually defining the elements, that is nodes and cable links in different workflows of NOCPlan. Let's first have a look on how maps are imported into the NOCPlan. Go to the option map, select add map. NOCPlan allows raster or vector map to be imported into the NOCPlan application. Maps can be road maps, street maps, or boundary maps, and all of these maps are in the form of .shp files. Maps have to be imported first into the NOCPlan application so that they can fall into the background on the GIS display area. The second input to the NOCPlan is through the CSV files. CSV files are already saved at some location, and user can import those files into the NOCPlan application. For example, sites from CSV, network from CSV, service areas and services, customer classes, densities, etc. Let's have a look how sites are imported into the from the CSV into the NOCPlan application. Select the CSV file from the saved location and import that file into the NOCPlan. Go to the workflow data mapping, and user can confirm all the sites that have been imported from the CSV into the NOCPlan application. Similarly, the data can be imported from other CSVs and can be checked into the corresponding workflows respectively. Now moving on to the manually defining elements for inputting data into the NOCPlan. For designing purposes in NOCPlan, workflows, define technologies, and network design is used. Define technology workflow addresses technology and architectural modeling tasks, and also the network design and optimization tasks associated with the network planning process. Define technology workflow basically models access network design, elements, nodes, links, resources, and topologies using the concept of connection models. Component models provide a grouping mechanism that allows equipment and nodes that share common characteristics such as vendor, version, and technology to be associated. The access network provides these components and their requirements which are used in the network for the network dimensioning. In NOCPlan, another is the 6 different layers we can use: demand layer, wireless, PON, cable, blown fiber, conduit and constraint category. Within each network layer, the link models, system types and the connection models are defined. Demand layer is the highest layer of the network layers. It provides the logic of the connectivity and maps the end-to-end service demand to the network technologies that will satisfy it. In demand category, user can create links in the star topology. The connection model is nothing but the set of rules which we define based on the technology requirement from the customer, and NOCPlan will plan the network as per the connection model. We can define the downstream and the upstream ports usage based on the links we use in the connection model. Let's have a look at one of the connection models. This connection model has 2 levels which define all the links, the services that those links will serve and the node information used in both the links. Under component groups, user can find the different nodes used for the planning and different links, demand links used. Next is the constraint category. The constraint category captures the allowable topology of the physical structures that support the cables. Cable placements will always be routed over the constraint layer links by the design algorithm. The constraint category is the lowest underlying layer. It is the layer over which the algorithm routes other layers. A system type can be defined as which defines the properties that are used for a logical relationship among all the links in the layer. Constraint layers can have chain or mesh system type. With the help of a system type, user can actually restrict the use of a fiber and can define the branch nodes and the cable node, root nodes that will be used in the system. Also the root cables and the branch cables. The quantity can also be defined to show the usage of the fiber. Now moving on to the workflow network design. In the network design workflow, the customers and services that were defined in the defined market and the sites and service areas that were mapped in the data mapping are connected using the technologies and chains modeled in the defined technology workflow. Network design basically consists of 3 tabs: network tab, design tab and a rollout tab. Network tab contains network elements repository and network layout in the GIS. Design tab contains the list of all the connection models and the sites and the service areas present for a particular project. Rollout tab allows the user to calculate the network rollout costs. A network design can be carried out several times within a single project using different connection models, which results in accumulating network design, network elements, rollout costs. Click on any of the connection model and run design algorithm. Click OK. The design will begin to run. Once the design is run, click on OK and user can see that the network is designed with all the links and the nodes placed to serve a particular site. Go to the tab rollout and click calculate rollout costs all the cost associated with the nodes and the links will be linked and rollout is calculated. This orange symbol indicates that rollout has been done. Once the network planning is done for a particular area, NOCPlan allows the user to generate different reports like bill of material report, construction cost report, and demands report. Go to the option Tools, Plugins, and here you can see list of reports that you can extract from NOCPlan application. A bill of material reports is nothing but the information on the cost incurred for different years of planning and quantity of all the nodes and the links used in the network. Demands report lists various service areas, downstream nodes and upstream nodes, and the last mile node in the system that it connects to. Construction cost report contains the information on all the costs incurred for different planning years and quantity of all the nodes and links used in the network. NOCPlan XS also provides a workflow called economic analysis, which provides a summary of the project related financial results such as revenue, cost, cash flow, and net present value calculations for different technologies. Once the user clicks on apply, user can actually compare the various results. User can compare various projects also under this economic analysis workflow. NOCPlan XS basically helps to reduce planning time and cost by 75%. It helps to reduce the design process from 8 to 2 weeks. Results that are obtained from NOCPlan XS are more cost effective and savings are projected from 5% to 10%. NOCPlan XS reduces engineering and construction cost. It also helps to reduce time to market and for revenue generation. That is all about NOCPlan XS tool. Thank you.